Good evening all of you. In this video we'll see answers for questions from 11th to 20th. So in the 11th question he is given a circuit and he is asking us to find what is the Thevenin's voltage. So let us see. So in this circuit he is asking us to find what is the V Thevenin. So if I want to find VThevenin is nothing but voltage across this impedance Z2. So just apply voltage division rule to find the Thevenin's voltage. Okay. So VThevenin is equal to total voltage multiplied by impedance Z2 divided by total impedance, that is Z1 plus Z2. So you check the options. You have option B, which is V multiplied by Z2 divided by Z1 plus Z2. Let us go with the 12th question. Norton's current is equal to the current passing through the dash circuited dash terminals. So it is the short circuited output terminals. So option B is the correct answer. Let us see 13th question. In the circuit shown, determine the value of load resistance when the load resistance draws maximum power. So according to maximum power transfer theorem, when load resistance is equal to source resistance, maximum power transfer from source to load. So if I take RL such a way that it is equal to the source resistance, that is RS is 25 here. So if I keep RL is equal to 25, then maximum power will be transferred from this 50 volt source to the load resistance RL. So RL is equal to 75. So option B is the correct answer. Let us see 14th question. For the reciprocity theorem to satisfy the ratio of response to the excitation before and after the source is replaced should be same. So it is just the reciprocity theorem statement. The ratio of excitation to the response must be same even after interchanging the source and load. Okay. Let us go with the next question. What is the number of links for the network of 10 branches and 4 nodes? So number of branches B is given, that is 10, and number of nodes N is also given, that is 4. So number of links, we have formula, number of links is equal to number of branches minus number of nodes plus 1. So here branches B is 10, so 10 minus 4 plus 1, that is 7. So option A is the correct answer for 15th question. Let us go with the 16th one. A terminal where there are more branches meet is known as, 3 or more branches meet is known as. So if 3 or more branches meet at a point, that one is called a node. So option B is the correct answer. Let us go with the 17th one. Number of nodes in a graph is 4. Number of trees in the graph is. So number of trees in any graph having n nodes will be equal to n square. So 4 square is 16. So if there is a graph having 4 nodes, then there are 16 possible trees for that graph. So answer is 16, that is option B. Which network topology term got reference directions and marked on the edges of the graph by arrowheads? So that a graph with directions marked with the arrowheads is known as oriented graph. So option B is the correct answer. 19th question. Consider the circuit shown below. Find whether the circuit satisfies Thevenin's theorem or not. So what Thevenin's theorem states? According to Telegan's theorem, the power supplied by the source must be equal to power dissipated in the loads. So here one source, 10 volt source is there. There are two resistors 4 and 1. So if I want to find current flowing through this circuit, I is equal to 10 divided by 4 plus 1, that is 5. So 2 ampere is the current flowing in this circuit. So if I want to find, first what I would like to do is, I want to find the power supplied by the 10 volt voltage source. So power is equal to voltage multiplied by current. So voltage is 10 volts and current flowing in this circuit is 2 ampere. So 10 multiplied by 2, the power supplied by the source is 20 watts. Now power dissipated in 4 ohm resistor is given by I square into R. So I is 2, 2 square is 4, 4 multiplied by 4, 4 for the 16 watt. And power dissipated in the 1 ohm, now you find P1 ohm is equal to I square, 2 square, that is 4 multiplied by 1, that is 4 watts. So if you add 16 plus 4, that is also equal to 20 watts. So the power dissipated in the network is 20 watts and power supplied to the network is 20 watts. So power supplied is equal to power dissipated. So it is satisfying the Telegan's theorem. So answer is satisfies. Option A is the correct answer. Now let us go with the 20th question. The internal resistance of voltage source is 10 ohms and has 10 volts at its terminals. Find maximum power transfer to the load. So we have a source with 10 volts and there is a source resistance of 10 ohms. Now he is asking us to find maximum power transfer to the load. Okay. Find maximum power transfer to the load. So in order to transfer maximum power to the load resistance has to be equal to source resistance. So I am taking load resistance as 10 ohms. So current flowing through this circuit I will be 10 divided by 20, that is 0.5 ampere. So if I want to find power dissipated in the maximum power, P is equal to V square by 4 RL you can do directly, otherwise already you know current. So I square into load resistance RL, if you do, you will get the maximum power. So 0.25 into RL is how much? 10. So you will get 2.5 watts. So option D is the correct answer. Otherwise you can find with the help of V square by 4 RL also. V is 10 into 10 V square divided by 4 into RL. RL is how much? Again RL is 10. So the 10 cancel. 4 2 is 8, 4 5 is 20. Okay, 2.5 watts is the correct answer. Okay, thank you all.